Welcome to Civil Projects of Onumoy. It is well known that almost all buildings materials expand or contract due to change in temperature and variation in moisture content. The magnitude of such expansion or contraction depends upon the type of material used in construction and the extent of variation in the temperature and moisture content. In a continuous structure, the cumulative effect of dimensional changes in the building elements may be considerable. In case components of such a structure are not allowed free movement, internal stresses will be set up which may result in formation of cracks. This may in turn endanger the stability of structure. Such a problem gains special importance in tropical countries like India, where large variation occur in the atmospheric temperature and humidity. Thus, special provisions should be made to control or isolate thermal and other movements to avoid danger to a structure. This is achieved by breaking the continuity of a structure by introducing joints at irregular intervals. These joints subdivide the building into smaller units and also permit free movement of each units. There are five types of joints in which expansion joints are provided to accommodate the expansion of adjacent building parts and to relieve compressive stresses that may otherwise develop. Based on this formula, it is seen that a structure 30-meter long expands linearly by about 10 mm through a temperature change of 50 degrees Fahrenheit. When one portion of a building is higher than the other, the soil below the higher portion will be subjected to greater pressure than the soil below the lower portion of the building. In such cases, it is desirable to have complete separation of the parts by providing an isolation joint. This arrangement permits vertical movement of the building parts due to difference in the unit soil pressure without causing any damage to the structure. In a similar manner, if one portion of a building rests on rock and the adjacent part on compressible clay soil, the two parts should be separated by providing isolation joint. We know that when concrete sets and hardens in air, it sinks in volume. Hence, concrete mix having more water sinks more than a concrete mix having low slump. The contraction caused due to drying shrinkage result in development of tensile stresses in concrete. When such tensile stresses exceed the tensile strength of concrete, it results formation of random cracks. Contraction joints are installed to allow for the shrinkage movement in the structure. In general, building continues to dry out during its lifetime, and as such dimensional change due to shrinkage should be taken care of in its planning and detailing. Sliding joint is provided between two parts of a structure when one part has a tendency to slide over the other due to variation in temperature and moisture content. Installation of construction joint become necessary to ensure proper bond between the old work and the new one. If it is possible to plan construction in such a way that the day's work aimed at an expansion or contraction joint, the need for construction joint will not arise. However, often it is difficult to complete the concreting for a large work in one operation, and as such special measures are necessary to be taken to achieve perfect continuity between the old concrete that has already set and hardened and the new concrete. In general, building of ordinary size and regular shape in plan can resist the stresses caused by dimensional changes and as such do not require provision of expansion joints. However, provision of one or more expansion joints is considered necessary when the continuous length of a structure exceeds 45 meter. There is wide divergence of opinion regarding proper spacing of expansion joints. In India, the recommended maximum center to center spacing of expansion joints is 30 meter. In addition, expansion joints should be provided where a structure changes direction, for instance, in L, T, H, and U shaped structures. Where two or more expansion joints are considered necessary, it is desirable to locate the joints in such as way that the distance of joints from the nearest continuous corner does not exceed 15 meters. The joint is formed by providing an initial gap between the adjacent building parts which gets widened or shortened while accommodating the contraction or expansion of the building. The width of the gap should be sufficient to accommodate the maximum thermal induced movements likely to be encountered. Normally, it varies between 10 mm to 40 mm. There should be complete discontinuity of masonry, reinforcement, or concrete at the joint, and the gap should permit unobstructed movement of adjacent parts. The recommended spacing of expansion joints for different types of works as per IS 3414 and is given in this table. Attempt should be made to treat the expansion joint in such a manner that it provides neat appearance and serves as architectural feature in the building. The detailing of joint should also be made as simple as possible. All that is needed is to fill the gap of the joint with suitable compressible material so as to ensure wind and water tightness. The materials used for treating an expansion joint are joint filler, sealing compound, and water bar. Joint filler is a readily compressible material which can accommodate the expansion of adjacent parts of the joints and has ability to regain 75% of its original thickness when pressure is released. In addition, it should be durable, resistance to decay due to weathering and termites, etc., and rigid enough to permit formation of straight joint. Joint filler can be made out of a variety of material such as bitumen, bitumen containing cellular materials, cork strips, natural or cellular rubber, expanded plastic, mineral fiber, coconut, pith, etc. The function of the sealing compound in a joint is to seal the joint against passing of moisture and to prevent the ingress of dust, grease, or other foreign matter into the joint. It should be insoluble, non toxic, and tintless and should be readily workable for placement in position. Mastic or hot applied bituminous sealing compound is commonly used for this purpose. The function of water bar is to seal the joint against passage of water. The water bar may be of natural and synthetic rubber, polyvinyl chloride, or of metal. The rubber or PVC water bars are manufactured in a variety of different forms such as dumbbell type, center bulb type, etc. The metal water bar consists of thin strips of copper, aluminum, or other corrosion resistant metal. Galvanized iron sheet water bars are also recommended in view of high cost of copper. However, GI water bar should not be used under corrosive conditions. The width of the metal water bar normally varies from 150 to 200 mm and thickness should not be less than 0.56 mm gauge. The metal water bar should have a U or V fold in the middle to allow the expansion and contraction at the joint. Here, we got the knowledge of different types of joints preventing cracks in construction work and the filler materials to protect the architectural view. The causes of cracks are not only the variation of temperature or moisture content in concrete but also the variation of soil stratum, different types of material used, or interruption of work. We shall discuss the type of joint material used in different position in our next part. Thanks for watching. If you like my video, then please like, comment, share and subscribe.